Welcome back to Simplified Chemistry. In this video, I'm going to cover the topics of relative formular mass and relative atomic mass. By the end of this video, you should be able to calculate the relative formula mass of any given compound. The relative formula mass has got a symbol of Mr, and it is defined as the sum of the relative atomic masses of the elements shown in the formula of a compound. This applies to both covalent molecules and ionic compounds. Relative atomic mass of an element. By definition, the relative atomic mass of an element is the relative mass of its atoms when compared to the mass of carbon-12 atom. In chemistry, carbon-12 is taken as the standard atom with a relative atomic mass of 12. All other atomic masses are relative to this mass of carbon-12. How do we use these relative atomic masses to calculate the relative formula mass? First, you have to know where to find that information. You always be given the relative atomic masses of elements in a periodic table. There is no need to memorize these numbers, as they're always at the back of chemistry textbooks, and if you're sitting an exam, you'll be given a data sheet. In the periodic table, there will be elements, for example, carbon, and each element will be represented by a symbol. For example, carbon, it's C, and you'll have its relative atomic mass and its atomic number. For carbon, the atomic number is 6, and the relative atomic mass is 12. Now let's look at a few examples of how to calculate the relative formula mass of compounds. For example, calculate the relative formula mass of carbon dioxide, given the relative atomic mass of carbon is equal to 12 and that of oxygen is equal to 16. Remember that the relative formula mass is equal to the total sum of the relative atomic masses of all the elements in a formula. Identify the elements in the formula. We've got the carbon element and the oxygen element. Second, determine the number of the atoms present for each element. We have 1 carbon atom and 2 oxygen atoms in carbon dioxide. Therefore, the RFM of carbon dioxide is equal to 12, which is a relative atomic mass of carbon, times 1, because we have only 1 carbon, plus 16, which is the relative atomic mass of oxygen, times 2, because we have 2 atoms of oxygen. And this is equal to 12 plus 32, which is equivalent to 44. Calculate the relative formula mass of calcium hydroxide. Now you want to be a little bit careful here because we've got brackets. The number that is outside the brackets applies to all the atoms that are enclosed in the brackets. Now let's start by identifying the elements that are present. We have calcium, oxygen, and hydrogen. Let's determine the number of atoms for each element. 1 calcium atom. In this case, we've got 2 oxygen atoms and 2 hydrogen atoms. To determine the relative formula mass of calcium hydroxide, we multiply 40, which is the relative atomic mass of calcium, times 1, because we have only 1 calcium atom, plus 16, which is a relative atomic mass of oxygen, times 2, because we have 2 oxygen atoms, plus 1 times 2, because we have 2 hydrogens, which is equivalent to 40 plus 32 plus 2. That gives us 74. Calculate the relative formula mass of copper-2 sulphate, containing 5 molecules of water. Given that the relative atomic mass of copper is 64, sulfur is 32, oxygen is 16, and hydrogen is 1. If you're feeling confident at this stage, feel free to pause the video and see how you get on. Right. When you encounter such a problem, first split the formula up into 2 parts. For example, here we have copper sulphate and 5 molecules of water. Let's deal with each part. For the copper sulphate part only, follow the same principles. Identify the elements, which is copper, sulfur, and oxygen, followed by determining the number of atoms for each element. We have 1 copper atom, 1 sulfur atom, and 4 oxygen atoms. Therefore, the relative formula mass of this part of the formula is equal to 64 times 1, which is equivalent to 1 copper atom, 32 times 1 for 1 sulfur atom, and 16 times 4 for 4 oxygen atoms, which gives us 64 plus 32 plus 64, which is equal to 160. Now let's do the second part. The second part contains 5 molecules of water. Find the RFM of 1 molecule of water and multiply it by 5. This is the simplest way of doing it without losing track of how many hydrogens or oxygens you have in that part of the molecule. The RFM of 1 molecule of water is equal to 1 times 2, because we have 2 atoms of hydrogen, plus 16 times 1, because we have 1 atom of oxygen, which gives us 18. To get the RFM of 5 molecules of water, multiply the RFM of 1 molecule of water with 5. This gives 90. Now let's bring it all together. The RFM of the copper sulphate crystals with 5 molecules of water is 160 plus the 90, which is equal to 250.